In the second part of the lesson today, we're still going to be solving absolute value equations, but in this case, we're going to look at equations that have two absolute value bars in them. In the previous examples, we only had equations where they had one absolute value bar. Now, the first thing they want us to do is they want us to solve this particular equation graphically. So what we're going to do is in y1, we're going to put in the left-hand side of this equation, which is the absolute value of 2x minus 3 minus the absolute value of x plus 4. And in y2, we're going to put in 8. And we're going to find our solutions using those particular situations. So, clear out everything that's here. So we're going to take the absolute value of 2x minus 3. Don't forget to close your brackets. And we're going to subtract the absolute value of x plus 4. And we're going to put 8 in y2. I'm going to change my window settings. I'm going to make my y max 14, just so it's a little bit higher so that my point of intersection isn't actually way up at the top of my screen. The other thing I need to note is that it appears that this absolute value graph is going to go up and that we're going to have a point of intersection over here on the right somewhere. So I'm going to have to increase my X window settings. So I'm going to make my X max 20 in this case. That should be big enough to see both points of intersection. And we are going to quickly find both points of intersection. I'm going to scroll to the left and just above my point of intersection, keep hitting enter, and I'm going to find that my left-hand point of intersection, I must have hit enter too many times. So enter, enter, enter. There we go. Our left-hand point of intersection has an x value of -3. So one of our solutions is x is -3. Now we're going to go ahead and we're going to find our right-hand point of intersection. Scroll over to the right and then hit enter 3 times, and it tells us our x value of that point of intersection is 15. So we know our solutions to this situation are -3 and 15. Now what we're going to do is we're actually going to look at this same situation algebraically. So what we're going to do is we're actually going to look at three situations when we go to solve this algebraically. This first situation that we're going to look at, I'm just going to ignore what's up here. It's kind of a little bit confusing, and I think it doesn't help us at all. If you look, we wrote out our original equation, which was the absolute value of 2x minus 3 minus the absolute value of x plus 4 equals 8. And what we're now going to do is we're going to look at the negative of both of these situations. If we take the negative of 2x minus 3, that gives us -2x plus 3. And we're going to take the negative of x plus 4. So that makes it -x minus 4. Now that doesn't change the sign in the middle. This still stays as a negative. If we solve this algebraically, and you can work through this, the solution we get is -1. And you'll notice that -1 was not one of our solutions when we did this graphically. If you check -1 back in the original question, 2 times -1 is -2. -2 minus 3 is -5, and the absolute value of -5 is 5. -1 plus 4 is 3, and the absolute value of 3 is 3. Well, 5 minus 3 does not give us 8. So this is not a solution to our problem. The next situation, in this left situation, we looked at both absolute values being negative. In this next situation, we're going to look at one of these being negative. So we're going to take 2x minus 3 and we're going to take the negative of it. And we're going to look at one of these being positive. So we're going to leave the x plus 4 alone. We're not going to do anything else with it. So if we distribute this, we get negative 2x plus 3 minus x minus 4 equals 8. Well, negative 2x minus x is negative 3x. 3 minus 4 is negative 1. Well, if we add 1 to the other side, we get 9. So we get negative 3x equals 9. And if we divide by negative 3, we get x to be negative 3, which indeed was one of our solutions when we did it graphically. And if you check negative 3 in the original equation, it will work. So we did both negative, one positive, and now we're going to do both situations being positive. So we're just going to take 2x minus 3 minus x plus 4 equals 8. So that gives us 2x minus 3 minus x minus 4 equals 8. 2x minus x is x. Negative 4 minus 3 is negative 7. And if you add 7 to the other side, you get 15. And that does check out. So the situations you're going to have to solve when you're doing multiple or more than one absolute value bars is you're going to have to do where both absolutes are negative, where one is negative and one is positive, and where both are positive. You're going to have to check all three of those situations when you're doing a problem. So we're going to go ahead and we're going to do one more example similar to this. But I'm going to do this example on, well, no, we'll do it here. We'll do it in your book. It's similar to what we're going to do. If you look at the right-hand side, the far right-hand side here, they've done the situation where both of these are positive. They kept the x plus 4 positive. They kept the x minus 2 positive. And when you solve this, you got 4 equals negative 2. Well, we know 4 does not equal negative 2, so that doesn't work. So the two other situations we're going to do is where one's negative and one's positive, and where both of them are negative. So if I take my x plus 4 and my x minus 2 and I make both of them negative, that means I'm going to put them in brackets and put a negative in front of them. I distribute the negative and I get negative x minus 4 equals negative x plus 2. Well, if I add x to negative x, that means I have no x's left. So I'm left with negative 4 equals 2. Well, we know that's not true. That's not a solution in this case. The third case, we're going to look at where negative x, we're going to take the negative of x plus 4, and we're going to take the positive of x minus 2. So we get negative x minus 4 equals x minus 2. If I add x to the right side, I get 2x minus 2 equals negative 4. If I add 2, I get negative 2 equals 2x. And if I divide by 2, I get negative 1 equals x. And if you check negative 1 back up here in our original equation, negative 1 plus 4 is 3, and the absolute value of 3 is 3. Negative 1 minus 2 is negative 3, and the absolute value is 3, so it actually works out. And there we go.